find our queue system again. Okay. Just as a reminder, we can identify all the classes, person, 2, 3, 4, 5, 6, 7. Okay, maybe if I can go down here and try to do this in UML instead. Okay, I guess the first part that is quite easy is to say, well, we have a person. I'm not going to bother with the fields and the methods, but you can imagine that there would be fields and methods here if I wanted to go that far. Okay, we had the course responsible, and now maybe I'll actually be a little bit more Java responsive. I really wish I'd written teacher. That would be faster. Okay, and again, this is a separate class. And what I'm saying here is, well, this is going to be a specialism of person. Okay, I want to inherit certain fields, methods of person, and you reuse those in course responsible. Okay, so this notion of inheritance is very powerful in object-oriented programming. Okay, you can create one object and then inherit everything from it, so you don't have to write out all again. So all the fields and methods up here are available down here. Okay, and we also had teaching assistant. Put this over 2 lines. Assistant, another class in our system. And again, they also inherit that as well. And the final one was, we shouldn't forget the students, probably the most important part of the system. Okay. And I don't think I can live without looking like a flag, so let me fix that. Okay, and again, this also joins this inheritance hierarchy, okay? And we could have multiple levels. We could have also inheriting from teaching assistant, we could have the super TA. I think, Amanda, you would accept that you would fit into that role, yes? So yeah, here we have it. Amanda as the example of the super TA, where they again inherit, and you can see how this forms 3 levels into a hierarchy. Okay, so the key here is I'm using this little open triangle to say these inherit from each other. Okay, so that's the first part of our queue system. The other part, we had the problems. Okay. That was a class. And we had the actual queue itself. And we had the course it belonged to. Okay. So this is kind of more on the content side. Okay. So we could say that I always get the direction of this wrong. So if someone wants to correct me on which side this goes on, someone who remembers UML, I always forget. Okay, we can say that that's maybe we can say that there's a student associated with the problem. Again, a student will post the problem and their Zoom link and all the rest. The queue itself is going to be made up with multiple problems. Okay, so we've got this idea that one queue might have many problems. I'm just using a star here to indicate many. Okay, and there is probably, a course associated with a queue or a queue associated with a course. Again, the direction here, sometimes it's just a dotted line. Again, the direction arrow might be a little bit funky here. Okay, and then all the TAs, when I think about this, there could be multiple TAs managing a queue. So I'm going to put, there could be multiple TAs managing a queue. There's not just one. So one queue could have multiple TAs, but multiple TAs might be on multiple queues in different courses. So I'm not entirely sure about that. So again, we can see how this starts to get a little bit squirrely when we try to model this way. And of course, the course responsible should be associated with their course to do all the management things and all the rest. Okay, so we have the inheritance. Over here, we have we have this diamond shape of, relationship. And here what we're saying is there's going to be an aggregation. Okay, there could be many teaching systems associated with many queues. There was one last arrow. If I just go back and remind us, we had this 2 diamonds. There was an open diamond and a closed diamond, which can make things super confusing. The other one, the closed diamond, is composition. And this is the idea that if we destroyed this queue, then if we like deleted that queue, removed it, whatever, then we would expect all the problems should disappear because they were all created within that queue. Okay, so this has a more serious implication. Okay, so this is a composition. A queue is composed of these problems. However, if we destroyed this queue, we should hope that all RTAs remain. They don't suddenly disappear. Okay, so we have this weaker form or this aggregation. Okay, I think the only other relationship I didn't actually write out was this as an association. Now, I always get a little bit confused with these different arrows and meanings. I think inheritance is the easiest one to get because you can see the levels coming out. The difference between association, composition, and aggregation is just different forms of strength of relationship. So again, it probably is quite clear here, like, yeah, if the queue was deleted, all the problems should be deleted with it because they were created within that queue. However, teaching assistants are quite independent of the queue. And so we still say that there are an aggregation of them, but if we remove the queue, the teaching assistants don't disappear. Jan says, if we remove the lab, students no longer have problems. That's a scary solution. Okay, crashing on. Okay, so, well, maybe not crashing on too quickly, but we can go from quite a loose, this is my sort of back of the envelope, what a solution might look like. And then I can start saying, using exactly the same class names, I can start to form more of a model of how they all relate together using a class diagram.